Well, now we have another equation to graph, and that is f of x equals x squared over 2 plus x. So the first thing we'll do is find the first derivative and the critical points. And so f prime of x, you need the quotient rule. I'm just going to give you the result after you use the quotient rule, equals 4x plus x squared. So please verify this by using the quotient rule and taking the first derivative. Anyhow, and another way to write that is factoring a x out, x times 4 plus x, and 2 plus x squared. Now, a couple things to catch up on. The domain is all reals except x can't equal -2. So there's going to be a vertical asymptote at x equals -2. Also, for the first derivative, the zeros of this, the critical points, are x equals 0 and -4. So there's -4, and here we are at 0. And here we are at 2, and at 2 we're undefined, of course. That's not in the domain. So now let's evaluate this derivative for these intervals, and if we pick a point less than -4, say -10, the denominator is always going to be positive. So -10 will have the quotient or the product of two negatives up here, and that's going to be positive. If we pick a value, say -3, between -2 and -4, -3, this will be will have the quotient of positive and a negative, of an odd number negative, so that's negative. Let's pick another value in this interval to the right of -2, like -1, and again evaluating f prime of -1, we get a negative value. So, and then evaluate f prime of some value greater than 0, and we'll get positive. So let's evaluate f of -4 and see what we get. And evaluating that, I get -8. Evaluating f of 0, I wind up with 0. So we've got quite a bit of work done. One more thing we have to do is the second derivative to verify concavity. And I'll tell you, I didn't simplify this. It's going to get messy. Matter of fact, what I have is a 2 plus x to the 4th power. You have to use the quotient rule, and it gets rather messy. And 4 plus 2x times 2 plus x squared, and then -2 times 4x plus x squared times 2 plus x. So use the quotient rule to get that, and without doing any more simplifying, if you evaluate something in the to the left of 2, like -3, I evaluated the second derivative of -3, and that happens to be less than 0, so it's going to be concave down on that interval from negative infinity to negative 2. Evaluating f double prime as 0, the result is greater than 0, so we'll be concave up to the right of 2. So I'm going to go ahead and graph this thing now. I think we can do it. And we're out here at negative 2, and we've got a vertical asymptote. And I'm going to call this negative 4, negative 8. And the slope is positive to the left of negative 4, and it's negative to the right of negative 4, and it's approaching, we've got a vertical asymptote at 2, and notice the concavity says if you're to the left of negative 2, it's going to be concave down. Now let's graph. Now notice from negative 2 to 0 we've got a negative slope, and when you get past 0 you've got a positive slope, and the concavity is greater than 0. So the second derivative verified what we just did, and of course this point here is 0, 0, so we're done.